All right, guys, so we are moving on to our next lesson, which has to do with compound interest. So our goal for today is to be able to interpret various parts of a compound interest problem and plug them into an equation. So this is going to look very similar to what we did with the exponential decay and exponential growth functions. The steps are kind of the same in terms of picking things out of the problem, labeling them on the side, and then plugging them into an equation. However, now we're talking about interest. Okay, so let's go into the definition. So the definition of compound interest is interest paid on a principal of an investment and any previously earned interest. So basically the bank pays interest on both the principal amount, so that's the amount that you first put into the account, and any interest that the account has earned over a number of time periods and depending on how many times it's compounded each year. So the equation is A equals P times 1 plus R divided by N to the N times T, where A is the final amount in the account. So that's normally what you're solving for. After how many time periods, how much money am I going to have in that account? P is the principal amount invested, so that's how much you are starting with in the account. At the very beginning, how much money are you putting into the account? R is the annual interest rate. N is the number of compounding periods each year, and we're going to talk about what that means here in a second. And then T is the number of time periods elapsed. Okay, let's go into N, so the number of times compounded. When you are going to find what the value for N is, you want to pay attention to a couple of words. First of all, any problem is going to say compounded. That tells you that you need to use this equation here. But in terms of how you decide what N is by these words here: annually, semi-annually, quarterly, monthly, weekly, daily. That tells you the amount of times it's compounded. So if the problem says compounded annually, that means that it's compounded one time per year, and you're going to use 1 for N. If it says compounded monthly, that means that it's compounded once a month, so a total of 12 times per year, which means that you're going to use 12 for N. Semi-annually is 2 times per year, quarterly is 4 times per year, weekly 52, and then daily 365. So depending on what you see in the problem will change what your N value is. So let's go into an example. Example 1 says an investment account pays 5.4% annual interest compounded quarterly. If $4,000 is placed in this account, find the balance after 8 years. So first of all, it says compounded quarterly. Now this is what tells us that this is the compounding problem, where we're going to use A equals P times 1 plus R divided by N to the N times T. Okay, now let's go ahead and identify all of our various parts. So we have A, which is the amount in the account after T time periods, which that's what we're trying to find out. We want to find the balance after 8 years. Okay, after that is the principal amount, so the amount that you first invest into the account. So it says if $4,000 is placed in this account, so the principal amount is going to be $4,000. Okay, now our interest rate, it says an investment account pays 5.4 annual interest, 5.4%. Now remember, we do not want to express this as a percentage. We want it as a decimal. So you're going to take 5.4, divide that by 100, and that is going to get you your decimal of 0.054. Okay, after that, N, the amount of times that it is compounded. So it says here it's compounded quarterly. So if we go back to our chart here, quarterly means 4 times per year. So my N value is going to be 4. And then lastly, T. After T time periods, in this case, we want to find the balance after 8 years. Okay, now that we have all of our pieces picked out, let's go ahead and plug it into our formula. So A equals P, so 4,000, times 1 plus R, so 0.054, divided by N, which is 4, to the N times T, so 8 times 4. All right, now to solve this, all you have to do is just plug that straight into your calculator exactly how you see it. So let's go to our calculator here. We've got 4,000. Open up your parentheses. 1 plus 0.054 divided by 4 to the 4 times 8. Okay, you plug it in exactly how you see it. Make sure that you have those parentheses, all right, because it will do the order of operations. It's going to divide that 0 or 0.054 by 4 before it adds the 1 to it. All right, so we press enter and we have 6,143.56. So our amount in the account after 8 years is $6,143.56. And this is our final answer. Okay, so our next problem, it says an investment account pays 4.6 annual interest compounded monthly. If $6,050 is placed in the account, find the balance after 6 years. So I encourage you guys to pause the video and try this problem on your own. It looks very, very similar to this problem here. Obviously, the numbers are a little different, and then also pay attention to how in this problem it now says compounded monthly. That is going to change your N value. So again, go ahead and pause, solve this, and then come back and I will show you guys how it's done. Okay, so go ahead and check how you plugged everything in. I wanted to do the solving part together so that we can use the calculator and kind of get familiar with that. But the principal amount is the $6,050. The interest rate is 4.6%, which as a decimal is 0.046. Now, because it says compounded monthly, that means that it is 12 times per year. So our N is going to be 12. And then it wants us to find the balance after 6 years. So we plug it into our formula here. And now let's go ahead and practice plugging that into our calculator. Okay, so we've got 6,050 times 1 plus 0.046 divided by 12. Close your parentheses, use the caret button, and then raise that to the 12 times 6. And we end up getting $7,968.77. And that is going to be our final answer. Okay, last example. It says, suppose that you now have $7,968.77 in your savings account. Your money has been earning 5% interest compounded monthly for 3 years. How much money did you start with? So this is a little different from our previous problems because it is asking us for how much money we started with. So we're solving for what P is this time. Okay, so let's go ahead and label all of our various parts here. We've got A. So that is the amount in the account after T time periods. So it says now that you have $7,968.77 in your account. That is what your A value is going to be. Okay, our principal amount, how much we started with, that is what we want to find out. How much money did you start with? Okay, our rate, our interest rate is 5%. So that as a decimal is 0.05. And it says it's compounded monthly. So again, just like the last problem, it's going to be 12. And then T, it has been compounded monthly for 3 years. Okay, now that we have everything, let's go ahead and plug it into our formula. Okay, remember we're solving for P, so we're just going to label it our variable. All right, now to solve this, all you have to do is simplify this portion here first, and I'll show you why. So let's go ahead and just plug in this value right here into our calculator. Okay, so we've got 1 plus, and I'm going to again put it in parentheses just like we saw it, 1 plus 0.05 divided by 12, and then raised to the 12 times 3. Okay, that gets us about 1.16, round to 2 decimal places. Okay, try to get it as accurate as possible. So 1.16, which means I am now in my equation going to replace all of this with 1.16. And now it's just like any equation. It's p times 1.16. So to get rid of that, to get p by itself, I'm going to divide each side by 1.16. And when I plug this into my calculator, my starting value, my starting amount of money is going to be $6,869.63. And that is how you solve for p.